All right. We are covering sections 1.6 through 1.10, which is a good chunk of material this week. Are there any sections that you had particular difficulty with, or ones that you really want to focus on today? I've done this class like before, like through the GSG. It seems that the ones that are very important are sections 1.6 and 1.7, just because like you're going to be using like natural logarithms and these exponential growth and decay functions, and it's important to have a pretty solid foundation for them. However, if you guys have any other questions about, let's see, what is 1.8? 1.8 is going to be about composite functions, I think, yeah. And then proportionality and power functions at 1.9, and then 0.10 is trig. So, thoughts, comments, concerns? If I don't have any requests, I'll just start at 1.6 and work our way forward. Okay, so logarithms. Okay, so we have a question, and it is, what does like the natural logarithm mean? So a logarithm is basically, if you think of the way that I find this easiest to like understand is that like if you're multiplying things, if you have like 2 times 3, that's going to equal 6. And if you have 6 divided by 3, that's going to equal 2. So multiplying and dividing are like inverses of one another, right? So if you do one, it like reverses the other. Are we cool with that? That being said, the logarithm, let's call this like log base 10 right now, of a number, we'll call that, I don't know, log base 10 of, let's just say x. There is an inverse of this function. So if I take log base 10 to the x and I raise it 10 to the log base 10 of x, that is going to equal x, because 10 to the power of something is the inverse of log base 10. So it's like basically reversing taking something to the power of whatever number is down here. That's how I kind of think of it. So if I have log base 10 to the log base 10 of 12, this is basically doing like the reverse function of taking 10 to the 12, if that makes sense. And so the way that you would get rid of that would be to take that to the 10th. So it's like, it's not as like easy to understand, because like if you're multiplying and dividing, you can kind of like imagine like physical objects being like proportioned out. Like if I'm going to like get 3 times more, then I'm going to add 3 times more. So it's like hard to visualize, but it's like basically the reverse of an exponent. And then the natural logarithm is going to be log base e. And so e is like a really important number, and it's a really handy number because it has just a lot of generally good things going for it that make it very easy to work with, which you'll find more so as you continue to work in the functions and like taking derivatives and like back in like the whole calculus thing. So e we like. E is a very good number. E is very easy to work with. And we like it when things are in the form of e. And so to have something that is log base e, it's just like, it's easier to say that it's the natural logarithm. So the natural logarithm is just the log with the base of e. And so if you were to reverse that, you would do it in this exact same way. You would say e to the ln x is equal to x. because this and this are two inverse functions. It would be like saying 2 times x divided by 2, because they're inversals. Does that clear things up a little bit, maybe? That's just kind of my off the cuff, like what it kind of, how I understand it. So, okay. So that being said, the really important things to remember is these, like, you're gonna have to get very comfortable with logs. This is not like something that you can just kind of like, there are some things that you can kind of skirt by in this class, but this is not one of them. You're gonna have to become very, very comfortable with logarithms. Even if you don't necessarily know exactly what they mean intrinsically, you're going to have to be comfortable working with them. So that's kind of the point of working in section 1.6. So we're just working with a logarithm that is base E. Okay, so let's do problem 6. And then let's do problem 12. So for problem 6, we have 100 is equal to 25 times 1.5 to the t. And so what we're doing here is we're solving for t. But t is in the exponent. Does somebody have a question? I guess not. Okay. So t is in the exponent. So we're going to get that out of the exponent by using logarithms. Because one of our properties of logarithms that we're going to have to memorize, unfortunately, this is one of those things that you just have to memorize, is that the natural log of, let's say, they call it natural log of e to the x is equal to x. And what the reason is there is because if anything's in a power position here, it gets moved out. So rather than saying this, how I would envision it is, and then xl, and then ln e is equal to 1. So that equals x. So that's why this rule kind of like makes sense, is because we're pulling these exponents out. And so we're going to use that same like concept when we're trying to solve this problem. First things first, though, I'm going to divide by 25, both sides, because I want to make this easier to work with. So I'm going to have 4 is equal to 1.5 to the t. And then just like I had to divide both sides by 25, if I'm going to take the logarithm of one side, I have to take the logarithm of the other. So I'm going to take the natural log of both, which is just log base e. So now I have ln 4 is equal to ln 1.5 to the t. And as I just mentioned, this is not just for, this is like a different log rule. It's ln a to the p is equal to p ln a. It's number 3 in your book. Basically, I'm going to move that on the outside. So this is ln t. This is t times ln 1.5. And then I can solve for t now because I have my t able to be isolated. So this is ln. And divide by ln 1.5. So t is equal to ln 4 over ln 1.5. Can I simplify this using any of my logarithm rules? Feel free to, yes, okay. Good, okay. Thank you for responding, by the way, in the chat box. That makes things a little bit easier for me to like have like a group session. What I was trying to highlight is the difference between this and this could be simplified into this, but these two are not equivalent. And this cannot be simplified. So you don't get to just, unfortunately, say that it's 4 divided by 1.5, the natural log of 4 divided by 1.5. It's the natural log of 4 divided by the natural log of 1.5. And so that's just something that's important to remember as you're like working with logs in the future, because that's something that I sometimes do. At least I look at something and I'm like, oh, I can just, but you can't. So that's unfortunate, but okay. Here's 12. How about you guys in the chat box walk me through how I should solve 12? Maybe so. I'm solving for t again. So, yep, I'm going to take the natural log of both sides. So I'm going to have ln A is equal to t ln B. And then I'm going to divide both sides by ln B. So t is equal to ln A divided by ln B. Exactly. Awesome. All right. Now let's try to apply these to some different problems. Let's do problem 18. So here we have something that we can recognize as exponential growth or decay. In this case, in problem 18, is it growth or decay? Oh, it's not going to have us solve anything here. Okay, well, I'm not really sure. Yeah, this is decay. It's decaying at a rate of 8%. Which we know from this number right here. And our initial value is going to be this number. This is last week kind of material. And then t is measuring time. Okay, so how about instead of that, let's do 22. So we are given p is equal to 2e to the negative 0.5 t. And we are asked to find whether or not it's growth or decay. And we need to put it in the form of the function. P is equal to p naught a to the t. Okay, so what's the difference between these two forms, first of all? So we have these two forms of the function. Can we move between them very easily? Like, what's the point of having two different forms? Okay, well, in this form, we can easily see if it's growth, decay, or see the growth decay rate, which is, that can be like visualized using A. Both of them kind of have this P naught that we can work with. And then this is in terms of E. So K is not going to be the rate. K is going to be like a little bit different. But it also does can let you know whether it's growth or decay. But the main thing about this is that it's in the form that has E in it, which means that we can easily use natural logarithms to easily simplify this problem. Okay, so, but we're not looking to simplify this problem, we're looking to switch forms. The first thing that I would do, just to prove that you are comfortable with what's going on, is I'm going to put these two equations together. So P is equal to P naught A to the T, and P is equal to P naught E to the KT. So we can say that these two are equal to one another, right? I'm going to divide both by P naught because I don't want to deal with that right now. So I have A to the T is equal to E to the KT. Basically, the takeaway from this is that A is equal to E to the K. Because, I mean, we could, okay. So I can explain this further in terms of rules of exponents if you want. So E to the K, if that is equal to A, then A, if I, okay. So I'm going to make this assumption. I'm going to assume this. But in order to prove that it's true, I need to prove that these two are equivalent. So I need to find A to the T, and so this would be E to the K to the T. And using rules of exponents, this is E to the KT. So it checks out. Exponentially speaking, this is fine. So A is equal to E to the K. So let me rewrite this problem. This is 22, I said. So P is equal to 2E to the negative 0.5 T. First of all, is this going to be growth or decay? Can we tell from this equation? So we're expecting it to be decay because K is less than 0. Then we're going to say that we know that our P naught is equal to 2, and that's consistent through both forms of the equation. And A, we know, is equal to E to the K. So we know A in this instance is going to be equal to E to the negative 0.5. And because E is a number, E is not a variable, right? E is just like a number, it's like 2 point something. I should know that actually. I feel like that's important. But let me type this into a calculator. And E to the negative 0.5, that is going to be 6065. So that is what A is going to be equal to. So I can rewrite this using basically exactly the same process. So I start with P is equal to P naught, which I know to be 2, is equal to A, which is 0.6065 to the T. Is this decay? Yep. But now I can more easily see that the decay rate is close to 40%. Without a calculator, you wouldn't be able to just say E to the negative 0.5 is equal to 0.6065. But it's important to just kind of understand how you swap between the two. Because sometimes it'll be easier to have it in one form and sometimes it'll be easier to have it in other forms. Usually the form you want to stick with is this form. But without a calculator, you're not going to really be expected to tell what that is. Okay, let's try, let me find a really good question. All right, let's maybe try 42. Okay, so during a recession, a firm's revenue declines continuously so that the revenue R, measured in millions of dollars in T years' time, is given by the function R is equal to 5 e to the negative 0.15 t. So calculate the current revenue and calculate the revenue in 2 years' time. All right. So this is asking for current revenue. What would I look for current revenue? How would I solve for current revenue? If it's current, if it's like at the time of start, it's going to be t is equal to 0. So this is going to be r is equal to 5 times e to the 0. And so this, anything to the 0 is equal to 1. So revenue is equal to 5. And this is measured in millions of dollars. So $5 million is what revenue is at this point. What about in 2 years? Well, t is going to be measured in years. So t is equal to 2 now. Now we have r is equal to 5 e to the, this is 2 times negative 0.15, so that's going to be negative 0.3. And then I can just simplify this using a calculator. Let me plug it in really fast. So that's e to the negative 0.3, and that is times 3.70. So revenue is equal to 3.70 million. So clearly there's been a decline, which was expected. So decay, given by that negative there. All of that makes sense. Okay, so what about part B? After how many years will the revenue decline to 2.7 million? How do we solve this? What is this question asking for? This question is basically asking, oh, yes, exactly. So you have it exactly right in the chat box. Basically what we're going to do is just set r to 2.7, fill out the rest of the equation, and then solve for t using our natural logarithms. So I'm going to take the natural log of both sides. Actually, that's a lie. I'm going to divide by 5 first. Then I'm going to take the natural log of both sides. So I'm going to solve this like you would on an exam without a calculator, just to show you kind of how to cope with not having a calculator. So then I'm going to take the natural log of this side. So I end up with So you have to do it to both sides. ln 2.7 over 5 is equal to natural log of e to the negative 0.5t is going to be equal to negative 0.15 t divided by negative 0.15 divided by negative 0.15. So t is equal to the natural log of 2.7 divided by 5 over negative 0.15. And this is how the answer would appear on your exam. It looks like a mess, but that's just how it kind of is. So, is this number positive or negative? Does this number make sense? Like, is this number, I see a negative sign here. Is that like a red flag for me? Like, does this seem like a right answer? Well, I know I have a negative, and I know I want t to be positive, which means that this must be negative. If this is going to be true, right? Because a negative divided by a negative is going to be a positive. Using my rules of log, I can show that it is because 2.7 divided by 5 is less than 1. And I know that because like 2.5 is about half of 5. So this is less than 1. And ln of 1 is equal to 0. ln of a number greater than 1 is positive, and the natural log of a number that is less than 1 is negative. So this is a negative number, this is divided by a negative, t is going to be positive, so this answer makes sense. That's just something that you can kind of keep in your back pocket. Just ask yourself, is this number positive, is it negative, does this answer make sense? So you can't have negative years. Okie dokies. Any questions about using the natural logarithm to solve problems? All right, let's move on to the next section. So this is going to be exponential growth and decay. Okay. Let's just start with number 2. Unless anyone has any specific questions about this section. I think that's enough. Okay. So we have this exponential function, which is y of x is equal to c e to the alpha x. And we know that it satisfies the conditions y of 0. Come on, mark it here. Y of 0 is going to be equal to 2, and y of 1 is going to be equal to 1. So we're asked to find c and alpha, and then find y of 2. Okay, where am I going to start? Which one is going to be easiest to find, c or alpha? Yep, c is going to be the easiest one that we can find because c, we know, is initial when t or x is equal to 0, and we're given y of 0. So y of 0 is equal to 2 is equal to c e to the 0, so c equals 2. That was easy to find. Now I'm going to rewrite this equation because I know that C equals 2. Now I'm going to find alpha. How am I going to find alpha? I'm just going to plug in this next equation here. I'm going to say that y of 1 is equal to 1. So this is 2e to the alpha times 1, because that's what x is. So 1 divided by 2 is equal to e to the alpha. Natural log of both sides. Natural log of 1/2 is equal to alpha. And quick pro tip, this, I'm just going to make a little aside here. The natural log of 1/2. Can I use my log rules to simplify that? I can. So it's going to be the natural log of 1 minus the natural log of 2. Yeah. Natural log of 1 is going to be, as I mentioned earlier, this is 0. So the natural log of 1/2 is actually equal to the negative natural log of 2. So sometimes you'll have like an answer key, or not like an answer key, but like a bubble sheet that you have to fill in, and at least this happens to me a lot. I start panicking because the natural log of 1/2 isn't there, because they wrote it down as the negative natural log of 2. I don't know why. They just think it looks cooler, I guess. But don't worry, those two are the same thing, and you can always just use your rules of log to kind of refresh yourself on that. So alpha is equal to that. All right, so now we get to put together this equation to find ourselves y of 2. So so this is going to be C, oh, not C. It's going to be 2 times e to the ln, or negative ln2 times, this is a quantity, times 2, because this is y of 2. So y of 2 is equal to 2e to the negative 2 ln 2. You can put this into a calculator. At this point, you've pretty much solved the problem. You just need to stick in a calculator and see what happens. All right, so let's try number 10. All right, so world wind energy generating capacity, W, was 18,000 megawatts in 2000 and has been increasing at a continuous rate of approximately 27% per year. Assume the rate continues. So give a formula for W in megawatts as a function of time T in years since 2000. So now we're using words to construct an equation, which we've been doing for a hot minute now. So we're trying to find W, so W is going to be our main variable. So W is equal to, and this is in megawatts. What's my initial? My initial, according to the problem, is going to be it's going to be 18,000. So in the last problem, we had a question about the last problem. If the answer was going to be fine as e to, or 2e to the negative ln2 times 2, And basically what I did is I just moved that 2 in front. I just smooshed the terms together so I could get rid of the parentheses because I don't like using parentheses if I don't have to. And so these are the exact same thing. You didn't have to change it if you didn't want to. It's just like I can say 2 times 3 and 3 times 2 are the same thing, right? So the natural log of 2 times 2 versus 2 times the natural log of 2. Okay. So yes, our initial value is going to be 18,000. So we can put that in our equation. Then we have increasing at a continuous rate of approximately 27% per year. What does that mean? What is this equation going to look like? If we're given a growth rate, are we thinking something that is a to the t or e to the kt? It's going to be a to the t. Yeah. Because what we're going to do is we're going to have 1 point and then our growth rate, which is going to be 27% to the t. And so this is what our equation is going to look like. We have our initial, we have our 27% growth rate, and then we have our t that is going to be in years. Okay, so here's a function. This function will work. However, if we're going to solve this function, the easiest way to do that is to have it in the form e to the kt. Why is that? We can try to solve it. We're looking for w is equal to 25 or 250,000. If I were to try to solve it like this, I can divide both sides by 18,000. And for me, I'm just going to knock these zeros off the end to simplify my answer, and I'm not going to use a calculator again. So it's just like you would on the exam. Get rid of these last 3 zeros for both of them. So I'm going to make it w is equal to, w is equal to, what's going to be 25 or 250 divided by 18 is equal to 0.27 to the t. So now what do we do? Unfortunately, if we are to get t isolated, we need to use actually, I mean, we could just solve using the natural log. But then we're going to get a little bit messier numbers. But that's fine. So we could go through and try to find what k is, or we could just solve, which is, I think, what I'm going to do. So take the natural log. That is not pen. Take the natural log of both sides. So the natural log of 250 over 18 is equal to the natural log of 1.27 times t, because this t got brought down. And so t is going to be equal to the natural log of 250 divided by 18 divided by the natural log of 1.27. So I got a little confused partway through there, but that is what our t is going to be equal to. And that is when w is equal to 250,000 megawatts. All right, did everyone follow that process? Awesome. Okay. Are there any questions about how to solve this type of problem? dead air. So I think that's a no, and that's a good thing. Okie dokies. Do y'all want to talk about this new functions from old thing? So this would be section 1.8. Sorry, we've got a lot of material to cover today. We've got like 5 sections. So it's like crunch time. Okay. Let's start with question 4. So we know that f of x is, actually I'm going to color code this. F of x is equal to 5x. That's a lie. Wrong problem. F of x is equal to x squared. And g of x is equal to 3x minus 1. That is the right problem. So we are going to be looking for a variety of different things. We are going to be looking for f of 2 plus g of 2. Let's start with just a and b. So this would be f of 2 times g of 2. So what is this going to end up looking like? Like, how am I going to solve this? I'm going to start by saying I want to find f of 2. So I'm going to say f of 2 is equal to 2 squared. So that's going to be 4. And g of 2 is equal to 3 times 2 minus 1. So it's going to be 6 minus 1, which is going to be 5. So I'm going to simplify this problem from f of 2 to 4 plus 5. So that's going to be 9 for part A. And I can use these exact same numbers because f of 2 is 4 times g of 2 is 5. And so this is going to equal 20. So I can use these same numbers. Okay. So let me erase all of this. I should have just cleared all, but I guess I'm a little bit foolish. Okay. So then we have C and D. C is we're going to be looking for f of g of 2. And D is we're going to be looking for g of f of 2. How am I going to nest functions like this? Basically, how I start is from the inside out. So I start by saying, here I have g of 2. I need to find what that number is before I do anything else. So we already established from earlier that g of 2 is equal to 5, right? So basically, if g of 2 equals 5, then what this problem is f of 5. And so f of 5 is going to be equal to 5 squared, which is 25. So basically, this is just finding equivalencies. So we're going to do the exact same thing over here. If f of 2 is equal to 4, then what this problem is really asking for is g of 4. And g of 4 is going to be 3 times 4 minus 1, so that'll be 11. So that is problem 4 to start with. Does anyone have any real problems with these like nesting kind of problems? Sometimes they can be stressful. This is like actually important too. Like we're going to be taking derivatives of functions and simplifying them into like nested problems like this. So it is kind of important to conceptually understand how to pick out and solve problems like this. Okay, let's do Let's do 14. And so this is kind of a flash forward to what we're going to be doing in terms of like later on in the class. So we have the variable u, and we're going to be substituting it for the inside function to express the following as composite functions. So we have here in part A, we have y is equal to 5t squared minus 2 to the 6. Basically, what I'm looking at in this function is I have this chunk, right? And then I have this. So all of that is to the 6. But I can't necessarily simplify it right now in the way that it's written. So basically how I'm going to do that is I'm going to say u, and sorry, I'm going to say this now because apparently last semester some of my students had some trouble. When I draw a V, I tend to draw like a point, and when I draw a U, I always have a tail on my U's. So that's how to tell the difference between my U's and my V's. Okay, so I'm going to have u is equal to 5t squared minus 2. So this is the function u of t. 5t squared. And then I am going to simplify my function y. So this is no longer going to be a function y of t. This is going to be y of u. And so that's going to be, if u of t is equal to this, then I'm going to say that this is equal to u to the 6. Right? So basically, I just separated it out. Y of u, that's my composite function here. So it's y of u of t. What's a variable for this one? U. Variable for this one, t. Okay. Why don't you guys give part B a try? So just whenever you're ready, put your answer in the chat box. Exactly. So u is going to equal, oh, actually not quite. So what u is going to equal is going to be 0.16. Actually, no, you could do it that way too. Why not? So in the chat box, we said that wasn't necessarily my first gut feeling, but u is equal to e to the negative 0.6t, and then we would say that p of u is equal to 12u, and that's exactly right. So you can, I mean, like you are right. Sorry, like unequivocally speaking, you are correct. This is an answer to this problem. Just for future reference, the way that I would have solved it would have I'm kind of setting you guys up for integration here, which is way down the line, but I just, like, that's where my brain kind of goes. I would say that u is equal to negative 0.6t, and then p of u is equal to 12e to the u. But both of these are correct. So, yeah. All right. For 14, we also have part C. And that is going to be C is equal to 12 ln q cubed plus 1. So, what is going to be my internal function? What is my u? And then I'm going to need to find C. Again, I would pull this stuff out of the internal. Yep, I would do exactly that. I would pull this internal stuff out, and I would say that is u. And then this is 12 ln u. So yeah, all right. Let's do problem 22, and then we can move on to section 1.9. So this is not 12, this is problem 22. Oh, by the way, we are on page 64. Okay, so we are estimating, based on the graphs, we are estimating f of g of 4. So where am I going to start? This is, we're using the figures above the questions. I'm going to start from the inside and work my way out. So I'm going to find g of 4. So I'm going to say g of 4 is equal to, I'm going to go to my graph that is g. I'm going to find where x equals 4. And then I'm just going to move up and see what y equals. So when x is equal to 4, y is equal to 5. So g of 4 is equal to 5. And then I'm going to put that all back in. I'm going to say that this is really f of 5. And I can find f of 5 by going to the f graph, going to where x is equal to 5, moving up, and I'm going to see that f of 5 is equal to 1. So 1 is my answer. Let's also do 28, and I'll let you guys kind of take the reins here. So 28 is asking for f of 1. Where am I going to start? I'm going to go with inside out again. So I'm going to say f of 1 is equal to, and I'm using the graphs that are above this question now. So these are like the weird curvy looking things. And so f of 1 looks like it's like -1/2 to me. So that's what I'm going to write down. So now I'm going to try to find f of -1/2. And that is going to be, yep, -1. So that's how you solve these kind of problems using graphs. You just kind of use the graph to tell you what the function is equal to at a certain point, and then like you can get long chains if they really want to. G of f of g of g of f of 2, and like a million parentheses on the back end. But basically what you do is you start from the inside and you say, what is f of 2? What is g of that number? What is g of that number? And you can do that for eternity if you like. Okay, let's start with section 1.9. And this is dealing with proportionality and power functions. So this section, I mean, the section is like definitely important, but it's not like logarithm important, you know? So for this section, we're going to start with number 4. And so we have y is equal to 3 over x squared. And so we're trying to determine whether or not it's a power function. And if it is a power function, we're going to write it in the form y is equal to k x to the p and give the values of k and p. So is this a power function? Yes. Cool. What is going to be k? K is equal to 3 and p is equal to, okay, So you're close. In the chat box, they said 2. It's actually going to be -2 because we're dividing by x squared, right? So I'm just going to take this whole equation and just move it over here to show you guys. So y is equal to 3 x -2. This negative basically means that it is on the bottom. So if I were to say this, this is going to be equivalent to 3 over x squared. And because we're dividing, we have to be able to differentiate between whether or not we are multiplying or dividing. So there is a difference between y is equal to 3x to the -2 versus y is equal to 3x squared. And the difference is that x gets very large here as x becomes very large. This whole function gets very small because you're dividing by a very large number. And here, if x gets very large, the whole function becomes very large. So we have to be able to differentiate between whether or not we're multiplying or dividing, and the way that we do that is by the negative sign. It is going to be very handy for you in the future to be able to rewrite these as 3 times x to the -2, and then switching back in and out. But that's just something kind of to practice a little bit. Okay, so let's also try number 9. Here we have y is equal to 3 times 5x. Is this a power function? Nope, exactly. Because this is 5 to the x and not x to 5. And so we can't write it in this form. All right, let's also do problem 16. So here we're kind of writing an equation, I believe. So we're writing a formula. We're saying that the gravitational force F between two bodies is inversely proportional to the square of the distance d between them. So where am I going to start? I have a tendency to write down everything that I know to start off with. So I know that the force is going to be inversely proportional to 1 over. So the way that I do inversely proportional, did they use this sign when you guys were working in this section? Oh, they just used K. Okay, so basically, I'll quick explain this because, so basically what they did in this section was they said y is equal to kx. And so this is how they said proportionality, because y is going to be equal to something times x. When I do it, I use this, which basically means is proportional to. This little like weird alpha sign. But that's where I started with that problem. So we're going to do that exact same thing, but we're going to do it in the language that you're familiar with. So that is going to be F is equal to K. So that's proportional to 1 over, so it's inversely proportional to what is going to go underneath there. It's going to be the square of the distance between them. So that's going to be d squared. So I'm going to simplify this down into F is equal to K over d squared. And alternately, if we were going with my initial way of saying it, it would be F is inversely proportional to d squared. And so these mean the exact same thing. It's just here we're specifically saying that there's a K involved, and here it's just kind of like a general thought process. But okay. How about you guys try one and let's do 14. So you guys tell me what a formula would be for 14. We have energy that is expended by a dolphin that is proportional to the cube of speed v of the dolphin. So energy is going to be equal to watts Yep, exactly. So it's going to be k v cubed. So this v cubed, this is the cube of the speed, and the cube of the speed is proportional to the energy that is spent by the dolphin. Awesome. Let's talk about periodic functions, guys. Just kind of a poll going on in the chat right now. Who all is very comfortable with periodic functions? Versus rate it from 0 being I know nothing about periodic functions to 10 being oh, I can do these in my sleep. Where are you guys all at? Oh, that's awesome. A 9. Okay. Yeah, I remember one last fall I tried to just start and essentially cram a whole trig class into a GSG, and it was just not productive. So basically what I'm going to tell you guys is that if you struggle with periodic functions because you either haven't seen them in a while or they're really hard to work with, just kind of brute force memorize what you can. Page 74. This is really valuable information. Because you're not going to learn a whole trig class in the span of this week. So you are not expected to do that. Do not feel required to do that, because basically we're going to be using these in a much less trigonometry way and more of just this is a function. If we put a number in here, it spits a number out. Input, output. That is what we're concerned with. So you're going to want to remember that A is amplitude. The period of the wave is going to be 2 pi over b, and then c is the vertical shift. So this is all very important information, and the same goes for if that's a cosine there in the term of in the function. So that is all very important. Memorize this so that if you look at a function, you're able to tell what's going on with it. We are going to do problem 2, and I don't think that you guys will be forced to graph things, because I don't ever remember that being on any of these type of questions. But basically what this is going to be is y is equal to 4 cos 2x. So we are going to graph it right now, because if there is a random graphing question, I don't want you guys to be left unprepared. And I'm going to try to draw a straight line for once in my life. Okay. So where am I going to start? I think I should start with what my amplitude is. My amplitude is pretty easy because it's this number that is straight out in front here. So my amplitude is equal to 4. And so that means that my wave is going to be 4 above the 0 and 4 below the 0. And just as a general kind of cheat sheet, I'm going to draw over here. I'm going to say a sine wave is going to look like this, and so this is 2 pi, and this is 0, and then a cosine wave is going to look like this, so that is 2 pi, and this is 0. So basically the difference is where they start, and I would suggest just kind of like if it starts like at a high amplitude at 0, that's like, that just screams cosine to me. So I'm going to start there. I'm going to say we're not going to do a unit circle to figure out what everything really is. Been there, done that. Not as productive as it could have been. So we're just going to say that this is my high point. This is at x equals 0. My y is going to equal 4. And so that is as high as it's going to go. Because my amplitude is 4. Okay. So then I'm going to ask myself, do I have a vertical shift? Because that's an important question before I start graphing this thing. Do I have a vertical shift? No, I do not. So I know that I'm going to be starting and intersecting with that 0 line as I would normally. And then my final question is going to be, what is my period? And we know that period is equal to 2 pi divided by b, which is going to be 2 in this case. So my period, pi. And so basically what that means is that this whole thing, we're going to do a whole cycle by pi. So here is pi. And here will be 2 pi. Okay, and so what I drew over here is one cycle of a cosine wave, right? I start here high up, x equals 0, I go down halfway through. This is x equals pi, and this is going to be my low point, and then I'm back up to the top at pi over 2, right? So I'm going to kind of like make those alterations. I'm going to start by saying, okay, so when x equals 0, I'm at my, like at the peak of my amplitude. So I'm going to have a point here. And then at the end of my period, I'm going to start off exactly where, I'm going to end off exactly where I started. And the point is to make a continuous function there. So I know I'm going to have one period crammed in between these two locations. Then I'm going to ask myself, okay, so if this is my low point down here, what does that correspond to? Well, that's halfway through. So in the case of a regular period, it would be 2 pi, and then my low point would be at pi. In this case, it's going to be at pi over 2, halfway through. And so this is going to be -4, and that's where this is going to be. Okay, so then I have to ask where it's crossing 0. Here, it's crossing 0. Give me a sec. Let's make that. So here it's crossing 0 at halfway between 0 and pi. So this is pi over 2. And then this is halfway between pi and 2 pi. So this is 3 pi over 2. And what we're going to need to do is, again, we're going to divide each of these by 2. So this is going to be at pi over 4 and 3 pi over 4, because we're basically just taking half. And so we have 2 points here. Okay. And then from there, it's just kind of a matter of drawing in a pretty looking line. So it's like kind of got this like curve thing to it, and then it's gonna like bottom out, and then you're coming back up. So that is one period of this graph. In the next like pi section, so this is like pi, right? And so from pi to 2 pi is another pi. So in this next section, it's going to do this exact same thing. And then it will just keep going. So the point of this being a periodic function is that it's like always like bouncing, like, okay, so I start like at one point down and up and down and up and down and up, and it's just like it repeats itself forever. So things to remember about a periodic function is that you always have to end your period where you started it so that you can continue on without any seams. For instance, you can go backwards because you always end where you started. Okay, so that is problem 2. We are going to now try problem, let's do problem 6, just so that we're comfortable with this. So this is going to be y is equal to 4. Actually, let's not do 6. You guys have answers to odd problems in the back of your book, right? So you want me to do the even ones. Let's do 4 then, so that we have a sine wave in there. Oh, but 6 has the half. Now let's do 6. Okay. Okay, so 6. So this is y is equal to 4 cos 1/2 t. And t and x, basically, it doesn't really matter which one it is. So we're going to start by saying what's our amplitude. Our amplitude is equal to 4. We don't have a vertical shift. And then our b is going to be equal to 1/2. So our period equals 2 pi divided by 1/2. And so basically, this is going to be 2 pi times 2. And the way that I kind of do that is, strangely enough, it was like my high school physics teacher who like coined this language. It was like jump the fence. So if I have a fraction divided by like a fraction with a fraction in the denominator, I pull the denominator up and move it to the numerator. And the reason you do that is because this is 2 pi over 1 times, or 2 pi over 1 divided by 1/2. And so to do this division in fraction terms, you're going to basically multiply by the inverse. This is 2 pi over 1 times 2 over 1. So inverse, switch, and that's the fraction explanation for it. But that's something you're going to be doing a lot, by the way, is just messing with fractions and stuff to try to make it easy. So we know our period is going to be 4 pi. Let's draw this thing. There we go. We have a cosine, so we're going to start here. And then this is going to be -4. And so that's going to be our amplitude. We know that we're going to have here. And then we know that our period is going to end all the way over here at 4 pi. And so we're going to be all the way up here again. Okay. So halfway through is going to be 2 pi. And that is going to be our low point, if you remember. And then we're going to do another halfway. So this is going to be pi and 3 pi. And this is where my zeros will be. So to draw the line, it's just going to be like this. And then I can also draw. So there is number 6. Do you guys have any questions about graphing this function / pulling amplitude and period off of here? Amplitude and period are not so much going to be as important in the future, but just kind of like just kind of goes to like understanding the general gist of a periodic function. No questions. Okay, that's good. Are you guys feeling more comfortable with kind of approaching this type of problem? I hope that's the case. Okay, so let's do problem. Let's do problem 10, and then we'll wrap up with another one. So here's problem 10. A person breathes in and out every 3 seconds. The volume of air in the person's lungs varies between a minimum of 2 liters and a maximum of 4 liters. Which of the following is the best formula for the volume of air in a person's lungs as a function of time? Okay, so this is basically giving us words and trying to squeeze a formula out of us. First of all, is this going to be a periodic function? Like, can we even use a periodic function to model this? So I'm going to start by saying this. I'm going to draw it a little bit. So this is going to be 2. So this is going to be 2 liters. And then we know we have a minimum of 2 and a maximum of 4. And we're going between 2 and 4, 2 and 4. So our lungs are full, our lungs are empty, our lungs are full, our lungs are empty, and we just keep going. So that looks like a periodic function. So we're going to say yes to being able to model it with a periodic function, which is good because that's what the problem is asking. Okay, so then we're going to ask, so I just drew that, what's my vertical shift? Because I did not draw it on the 0 line. I drew it all the way up here between 2 and 4, right? This oscillation was happening. So what is my vertical shift? Okay, so 2 is a good answer. Also, somebody just said A is equal to 1, which is also correct. 2 is a good answer, but it's not quite right. It's actually going to be 3, because what we want is this line going through the middle. Yeah, so that's something that they're going to try to trick you on. Yeah, don't apologize. That's fine. So we want this line going through the middle of this function, and that is actually going to be 3. So we know our C is equal to 3. As I believe it was Ray said earlier, A is going to be equal to 1 because we're going from 3 to 4 and from 3 to 2. And then we are going to find B is our next big thing. Doesn't matter if we have sine or cosine. Why do you think so? So they are different functions, but basically they're just like a horizontal shift. And so that's why we never have any horizontal shifts going on here, is because, so cosine looks like that, right? And it just keeps going. So cosine kind of starts high at 0, and sine kind of starts here. So it starts at 0, 0. But basically, if I were to take this and shift it by like pi over 2, or let's not do pi over 2, let's do 3 pi over 2. So this is now x equals 0. Then I have a sine function, right? So it's just like horizontal shifts can like move between sine and cosine. So it doesn't really matter here if you have a sine or a cosine, because all that's really saying is like, do you start with your lungs full or empty or halfway in between? So a horizontal shift slash sine slash cosine is not really like the big like takeaway from this, because all we need to know is it's periodic and it's oscillating between highs and lows. So that's why all of the answers are sine, because it doesn't really matter. You'll notice that I drew this as cosine, starting at a high point and then oscillating from there. That's fine too. Okay, so we need to find our period. We know that y is equal to 3 plus sine. So we can knock off, this is a multiple choice question. So we know because of our vertical shift and because of our amplitude that it can't be A or C. So the big question is now, is the period, is B going to be equal to pi over 3 or 2 pi over 3? So the way that I'm going to approach this is I'm going to say if, because it's a multiple choice, so they're giving me an answer. So if B equals 2 pi over 3, then the period, which is like big T, sometimes they call it, so this is period. Period is equal to 2 pi over 2 pi times 3. And I just did the whole jump the fence thing where I took this and put it in the numerator. So T is equal to 3. And then if B is equal to pi over 3, then the period is going to be equal to 2 pi over pi times 3. And so this is going to be 6. Right? So now we need to ask ourselves, how often does this happen? And what it says in the problem is that at the very beginning, it says that a person breathes in and out every 3 seconds, which means that we go through a whole cycle. We go through in and, or rather, so the person breathes in and out every 3 seconds. So this is one period, and that's 3 seconds. And T is measured in seconds. So we're looking for a period of 3 seconds, and that is going to be given to us by 2 pi over 3. So yeah, so that is how we would solve this problem. Okay, finally, let's look at problem, let's do 26. And so here we have a graph asking us for a function. I'm going to kind of sketch the graph, but I would highly recommend looking in your books because my drawing is not always the best or most accurate. 3, that's 6. This is 6. This is 2. This is 4. Okay. So let's find a function. First of all, do we have a vertical shift? Well, because it's not based around a 0 line, I always just draw a dotted line down the middle so I can visualize it and compare it to what I know. And so I know that I have a vertical shift of 3 because I'm moving 3 up. And I know that my amplitude is going to be from 3 to 6 and from 3 to 0. So my amplitude is equal to 3 as well. Is this a sine wave or a cosine wave? Well, it's going to be, yes, exactly. We're starting at 3 or at 0, 3. So this is going to be a sine wave because it kind of has this shape, the way that it's drawn. So I'm going to kind of put all of this together really quick. I'm going to say that this is y is equal to 3 plus 3 sine, and then we need to figure out our period. Our period t is equal to, we know, 2 pi over b. And we also know that we go through one period every 8 units. So x equals 8. So our period also equals 8, according to our graph. So 2 pi over b is equal to 8. I have one variable, I can solve for the variable. I'll multiply both sides by b. 2 pi is equal to 8b, divide by 8. So b is equal to 2 pi over 8, or b is equal to pi over 4. So then I'm going to put that in there. This is pi over 4x. And voila, it's a function pulled from this graph. So this is like not like, this is important stuff, but like if you have to like take away anything from this class, don't let it be periodic functions. Like these are cool, but as long as you like understand that a periodic function is in fact a function, that if I put in an x value, I get out a y value, as with other functions, it's going to be cool. So from this point on, we're dealing with periodic functions in more of the sense that they are functions, rather than these are oscillating constantly, and this is what a period and an amplitude looks like. So big deal for this week, not big deal in the grand scheme of this class. That's what I have to say about periodic functions. Does anyone have any questions? Cool, that is a no. Okay, in that case, I think we're gonna wrap up for the night. Y'all have a great evening. If you guys have any questions, again, email me or comment, and like on any of the announcements or something, and I'll check in on those. And yeah, I am going to fix the Zoom link, and I'm going to see if they will post like a regular link that we can access, so that I don't have to constantly post a new one every week, or at least like get the recurring link working, because the recurring link wasn't working today, I guess. So we're going to get that figured out. But yeah, so this should work. Okay. Have a good evening, folks. Email me with questions. And thank you for coming.